solve the nonlinear system. This one looks really similar. X squared plus y squared is equal to 16. And this time it is y squared over 9 minus x squared over 16 is equal to 1. So again, we have almost the same construct. This is circle with center 0, 0, and radius r equals 4, no difference there. This is also a hyperbola. And the a value is 4, the b value is 3. The center is also 0, 0, but this one opens vertically. This is a vertical hyperbola. That is to say, this is negative x squared over 4 squared plus y squared over 3 squared equals 1. And because this is negative and this is positive, it opens, oops, I can't spell, vertical. Okay, so look, the graph here is going to be the same. Let's draw this really quick. Real similar stuff here. Get our circle in. Do that one in blue again here. Let's see. Perfect. There's our circle of radius 4. When it comes to the hyperbola, the dimensions are identical as far as our guiding box is concerned. It's going to be 4 in both directions for x and 3 in both directions for y. We're going to get this same set of asymptotes as well. So here I'm drawing that 4 by 3 box. Well, it's actually 8 by 6, but this is 4 and this is 3. We get our asymptotes in here. I can't draw. Okay, hold on a second. Come here. Get up there. There we go. But this time, because it opens vertically, the vertices of the hyperbola are above and below the center, and it will hug those asymptotes like this. So, let's see. Our points of intersection, as far as I can tell, if we get rid of all those construction lines very quickly, looks like we have 4 points of intersection. Let me put those, just visually, I wanted to show you guys that. I'll put those construction lines back in here. So it looks like we have 4 points of intersection. 4 points of intersection, i.e. 4 solutions to this system. But just from my graph, I couldn't really tell you where those are. I mean, I could ballpark it, but it wouldn't be accurate, especially since my drawing isn't that accurate at all. So we have to use algebra to go actually verify this. So that was step 1, graphing it. Let's go verify with algebra. So verifying with algebra, we have equation number 1, which is x squared plus y squared is equal to 16. And I'm going to rewrite equation 2 in an order that is easier to deal with. I want my x's first and my y's second. And I'm also going to actually multiply through by the common denominator, which is 144. So if I take positive y squared over 9 minus x squared over 16 equals 1, and I multiply that by the common denominator, 144, I'm going to end up with 16y squared minus 9x squared is equal to 144. So that's what I'm going to use here. Negative 9x squared plus 16y squared is equal to 144. So that's my new system that I'm going to deal with. Now, we're going to use some basic elimination. So let's see. Using elimination, let's just eliminate x. That looks like it's probably be easier. So let's do 9 times equation number 1 plus equation 2. So what will that give us? That'll give us 9x squared plus 9y squared equals 9 times 16, which also happens to be 144. And negative 9x squared plus 16y squared is equal to 144. And we'll add these two together. And that'll give us 0x squared plus 25y squared is equal to 288. Now that doesn't look particularly fun to solve, but we're going to do it anyway. This is our reduced equation. 25y squared is equal to 288. This means that y squared is equal to 288 over 25, which means that y is plus or minus the square root of 288 over 25. Now, I do not suggest that you rush your calculator to simplify this. You should be able to do this by hand. So let's go over this. This is plus or minus the square root of 288 over 5. That one's easy enough. Or this, I guess I'll do it in another step here. Let's see. The square root of 25. This is plus or minus, let's see, the square root of 288 we know is 2 times 144 divided by 5, and that's plus or minus the square root of 2 times the square root of 144 all over 5, which is plus or minus 12 root 2 over 5. So these are the y values. That's how high and low these are. So apparently, this is y equals 2 root 12 over 5. And this is y equals negative 2 root 12 over 5. So the question is now, what are the x values that go with those? So, case 1. If y equals 12 root 2 over 5. What did I write up there? Did I just write 2 root 12? Sorry. $12 root 2. 12 root 2. If y is positive 12 root 2, then we can use our first equation. Using equation number 1, where x squared plus y squared is equal to 16. What we have is x squared plus 12 root 2 over 5 squared is equal to 16. And that means x squared is equal to, x squared is equal to 16 minus 12 root 2 over 5 squared. We can simplify that a little bit. This is 16 minus, this is just going to become what it was before we took its square root, 288 over 5. And let's see here. If we get a common denominator here, oh, sorry, over 25, my bad. If we get a common denominator here, this will be 16 times 25 over 25 minus 288 over 25. And that's 400 minus 288 over 25, which is 112 over 25. So x is, that's what x squared is equal to. So x is plus or minus the square root of 112 over 25, which is plus or minus the square root of 112 over 5, which is plus or minus, let's see, 112 is 2 times 56. 56 is 2 times 28. 28 is 4 times 7. So it looks like this is 16 times 7. And we can break that up as the square root of 16 times the square root of 7 over 5, which is plus or minus 4 root 7 over 5. So what we have here is a single y value that generates two x values. As we saw up here, this particular y value generates two x values. So what are our solutions? Well, those upper two appear to be 4 root 7 over 5, comma, 12 root 2 over 5, and negative 4 root 7 over 5, comma, 12 root 2 over 5. For case 2, one could argue by symmetry here. If you realize that this is symmetric, then you could probably already guess that the negative y value, negative 12 root 2 over 5, is going to generate the same x values. And you can see that from this calculation, right? If I just steal this calculation here, duplicate, bring it down here. If we have y is equal to negative 12 root 2 over 5, and we use equation 1, this is just going to be, the only difference here is this is going to be negative, but when we square it, we're going to get the same result anyway, and we're going to get x is still plus or minus 4 root 7 over 5. So our ordered pairs from this second set are very similar. They are 4 root 7 over 5, negative 12 root 2 over 5, and negative 4 root 7 over 5, negative 12 root 2 over 5. And those are all of our points of intersection. And the solutions to this nonlinear inequality. So just to recap here, our solution set is plus or minus 4 root 7 over 5 and plus or minus 12 root 2 over 5.